All right. So Jensen Huang, the CEO of NVIDIA, recently made a statement that kind of caught my attention. And if it was from anyone else, you would probably chalk it up to just mere hyperbole. So here's what he said. Here's the full quotation. This was at a Salesforce Dreamforce event, by the way. So this was just a few days ago. He said, "This is an extraordinary time. In no time in history has technology moved faster than Moore's Law. We're moving way faster than Moore's Law, or arguably reasonably Moore's Law squared." So, Moore's Law squared, what did he mean by this? So I've got all the data here, all the research. There is some evidence for this, but it needs kind of a qualification. So, no, Moore's Law, which is basically, there's different ways of describing it, but basically that computational density is doubling every 18 to 24 months. But what has been going up is the amount of compute, and then also the efficiency of that compute with the software layer. So let me break this down. Here's one factoid, one bit of math for you. So from 1959 to 2010, the total amount of computational power doubled every 17 to 29 months on average. So that was in terms of what was actually physically available in the world. Because the thing is, think of it this way, even if you have the fastest CPU in the world, if there's only one of them, it doesn't really matter. So it's not just a matter of chip architecture or chip speed, it's about total number of chips. Now, from 2010 to 2022, so that 2010 cutoff, the doubling of total compute rose to double every 4 to 9 months. So that's significantly faster. So basically, whether or not chips have gotten that much denser, the number of chips has doubled very, very quickly. Now, that's just on the hardware side. So that's more about industrial capacity or capacity of chip fabs. Now, in terms of model performance, we're seeing all kinds of things like quantization and distillation, but here's an example of how fast you can get doubling or more or better performance. You can get orders of magnitude performance with optimizations and efficiencies. So ImageNet dropped, let's see, here we go. So ImageNet classification accuracy dropped from an error rate of 28% to 2% over the course of just a few years. And in that same time frame, the training time dropped drastically. So in October 2017, the training time was 13 days, but in July 2019, the training time was just 88 seconds. So just under a minute and a half. So hundreds of times faster. And this is kind of what we're seeing. Particularly if you've been using image generators, where back in the days of DALL-E, early days of DALL-E and Stable Diffusion, it was all really kind of wonky. But now we can get photorealism pretty reliably, and we're only a couple years in. Not only that, it is commercially available. It's not even in the lab anymore. Another way of thinking about it is the cost of compute. So using money as kind of a universal medium or a universal unit of account is actually pretty useful here. And Ray Kurzweil was just saying that the cost of compute, so basically how much it would cost to purchase, a teraflops or a petaflops or an exaflops of compute, has dropped. What did he say? It was like on the order of like trillions of times or quadrillions. I mean, it was many, many orders of magnitude. I don't have this quotation pulled up. And so when you look at this in aggregate, even if, the nanometer scale architecture of, silicon-based transistors, whether or not that's giving out, it almost kind of doesn't matter, because we are finding more and more ways to still get more juice out of this technology in terms of total amount of flops available, in terms of cost per flops, in terms of watt per flops, and so on and so forth. So what I wanted to do was I just wanted to kind of set the stage and then riff on, like, where are we going? Like, what's coming? So I watched the full interview with Jim Fan. So Jim Fan is one of the lead researchers on embodied robotics and foundation models over at NVIDIA as well. So Jim says that we're about 2 to 3 years away from robotic hardware that can match humans in terms of dexterity, in terms of flexibility, and so on and so forth. Now, obviously, robots are already stronger than humans and faster than humans and whatever else, because that's just machines typically do a little bit better than humans on those things. Like if you saw the Boston Dynamics robot being able to do backflips and parkour and stuff, it can do backflips better than I can. I would break my shoulder. I've tried. Now, so the hardware is 2 to 3 years away, but Jim also says that having a general purpose foundation model for robots is also about 2 to 3 years away. Now, you might say, okay, well, what's the difference between a robotic foundation model and, for instance, the foundation models that OpenAI and Google are working on? So a foundation model, if it starts with language, if it's a tokenization model, then its primary, its how do I say this? Its home base, its native environment is digital information, so files. This is going to be anything that can be tokenized, which includes text, images, video, those sorts of things. Now, NVIDIA is working on an everything to everything model. So basically, it can ingest any kind of input as long as it's data and output any kind of information that you want as well. But we suspect, and when I say we, I just mean people that I talk to, we suspect that you're probably going to have several main classifications of models. So you're going to have what Andrej Karpathy is talking more of like a cognitive model. So, the language models, the reasoning models, those are the more cognitive agents that are capable of reasoning, planning, problem solving, and that includes writing code, writing text, and that sort of thing. And then you're going to have more of the specialized models, which are AlphaFold and AlphaProteo, that's more like classical machine learning than what you would maybe call artificial intelligence today. But I digress. That distinction is more or less irrelevant. It's a computer that has learned to do something that humans can't do, and it can do it faster and cheaper than humans can on other conventional means. And so then you have the more robotics oriented models. And the robotics oriented models are going to be more for navigating high friction environments, using a variety of robotic chassis and that sort of thing. So basically think of it as like the droid brain that Anakin plugged into C-3PO when he was building him. You plug in a droid brain, and now the droid is able to, navigate the world, follow basic instructions, and so on and so forth. But you'll probably still need a separate reasoning engine, which is for higher order, complex problem solving, memory management, those sorts of things. Now, it is possible, and I'm not going to make a prediction one way or another. And the reason that I'm not going to make a prediction is because I could just as easily see it going one way or another. So what am I talking about? I could see everything kind of merging into like one model to rule them all one day. However, I could also just as easily see specialization models that end up, just basically being little peripherals. So for instance, I could imagine ASICs, so that's application-specific integrated circuits and neuromorphic chips, that basically ultimately just get integrated into a robotic chassis, and then you don't even need a robot foundation model. And in point of fact, this is probably the direction you'd want to go anyways. And the reason that you'd want to go that direction is because they're going to be, one, you can't hack them. You might be able to find exploits depending on how they work. But if there's no software to rewrite, and there's no IP protocols, if it's literally a piece of hardware that has no network connectivity, you can't hack it. And it's going to be more efficient. And you can mass produce it. And that efficiency is going to be really powerful because ASICs tend to not only be faster, but also less energy hungry. And when you have robots, especially if you're trying to scale up to billions of robots, energy efficiency is going to be really important, particularly for battery life, particularly for demands on the grid. So I would expect that once we start having, I guess, better general purpose robots, yes, you'll do a lot of it with at the software level, but think of it as like the brainstem. So the brainstem of a human, or I guess it's the cerebellum, is kind of responsible for generating a lot of the kinetic patterns. But that's why you can walk without thinking about it. Is that a lower order part of your body, which is basically a self-trained ASIC, is responsible for things like locomotion and manipulating objects in the world, which is why, like, every time you reach for your car keys or a door handle, you don't really have to think about what each finger is doing or even your whole hand or your whole arm. Now, you can consciously hijack that process, which will probably want robots with the ability to do, especially if they're improvising something new. But on the same token, if you can make something automatic and efficient, then you go that direction. So then, well, what's the role of language models? And of course, people are talking about building language model ASICs as well. So it might be that, like, again, this is why I'm not really willing to predict one way or another, because there's all kinds of form factors that I can imagine from a hardware and software perspective. And maybe we'll have all of them. Maybe ASICs make sense for many functions, particularly locomotion, and basic navigation of the world. Perhaps ASICs also make sense for some language purposes, particularly, let's say, running the optics and running the audio equipment. So basically, like, you don't need a super powerful language model to do text to speech or speech to text. You can just offload that to a basic ASIC. I did not mean to rhyme there. On the other hand, if we can get these models distilled and quantized, it might be more beneficial to just have a general purpose processing unit in the robot, and then you can swap out models as you want. I mean, there's all different kinds of ways this could go, and I did want to talk about the rise of robotics. So I guess what we'll do is, now that I've kind of set the stage where we're at in terms of hardware and software and models, let's just accept, for the sake of argument, that Jim Fan is correct, and that we're going to have basically human equivalent or human superior robots within 2 to 3 years. It seems like we're going to have human superior AI either by the end of this year or certainly by 2025. And that's going to be on, a vast majority of intellectual endeavors. Now, what does all that mean for the economy? What does that mean for our lifestyles? There's still going to be a few constraints. So number one is economies of scale. Even if, let's say, Sony and Boston Dynamics and Figure One and, basically and Unitree, let's imagine that literally everyone working on a humanoid robot announces tomorrow, we've done it. We've got a general purpose foundation model. This robot is just, it's more capable than any human. Look, here's a team of these robots that built a house and they did it in 4 hours. Here's another team of robots and they, let's say, like, they built a nuclear fusion reactor or something like that. They did, they participated in high energy physics research. Even if all of that landed tomorrow, it would take a while to build enough robots. So you've got to scale up production. Now, one thing that one comment that I saw a few different times and places was, oh, well, we don't have the resources to scale up, which is not true. We build globally, we build 70 million cars per year. There are something like 1.4 or 1.5 billion automobiles on the road right now. And one of the things that Jim Fan said is that a humanoid robot is about 4% of the resources of a car. So for every car you build, you could build basically 25 humanoid robots. And so it's like, okay, well, what if we took just some of the resources, and it doesn't even have to be mutually exclusive because steel is abundant, for instance. But let's just imagine you took those 70 million cars and instead you built, pound for pound the same number of robots. So let's see, 70 million. Here, let me just bring up a calculator. It's too early in the morning to do math. So 70 million times 25, that would be 1.7 billion humanoid robots that we could build each year with the amount of resources being contributed to cars right now. Now, obviously, that would drive up prices of things like batteries and steel and microchips and that sort of thing. But my point is that we already have the industrial capacity to build hundreds of millions, if not billions, of robots. It will just be a matter of allocating resources accordingly. Now, Those economies of scale will take some time. There's probably also going to be some integration hurdles. But then other comments that I've seen are people, both employees and employers, have both said more or less the same thing to me, which is like, if you can, if even if a humanoid robot costs $50,000, if it is remotely as good as a human worker, but can work tirelessly, like, if it starts to run low on batteries, it just tethers, just plugs in an extension cable, or better yet, has hot swappable batteries. Even at $50,000 a year and $10,000 a year of maintenance, it still makes sense to replace a human worker, because then you don't have to worry about the worker being out sick. You don't have to worry about the worker suing you. You don't need to worry about employment benefits. Then it's just a piece of equipment, not a human. But if that piece of equipment can basically run your whole garage, or do everything that you need to, like, it can clean up after itself, it can it can do work product, it can do your taxes, whatever, like, that is still worth it from an economic standpoint. So let's just imagine that, like, okay, a high-end robot that is capable of doing everything that any human can do, both physically and mentally, costs $50,000 in 3 years. Now, obviously, that price range is out of reach for probably most middle-class families. But one thing that someone else pointed out to me is, well, if they're that expensive, you just lease it like a car. You just set up a payment plan. Most people aren't going to be able to pay for that out of pocket. And because it probably will require maintenance and updates, most people are probably going to be on a lend-lease kind of deal anyways. So that's another thing to keep in mind, is just because a robot costs $50,000 doesn't mean that it's going to be out of reach. Because imagine it's like, okay, what if you have a payment plan, and let me bring up a quick car calculator. Let's see, car loan calculator. Give me just a second. I didn't really think through this. All right, Carvana's car loan calculator. Vehicle price, $50,000, down payment, 0, trade-in, 0, credit, loan term, let's say 72 months. Okay, so this is $900 a month for 5 years. So that's pretty expensive, but if that generates for you, if it either makes more than $900 a month for you or saves you $900 a month, that would still be worthwhile. I'm just imagining, like, how much would I pay if I had a full-time assistant at home that was able to do my video editing and do the dishes and, fix up the house. Like, I would gladly pay $900 a month for, a super powerful robot that was able to do all of that, could do my cooking and cleaning and my laundry and, all home maintenance and help me with my business. That would be worthwhile. So even at a $50,000 price point, that would probably be more than worth it for me. I would probably spend more on that robot than I would on my car, because then guess what? It can also probably do my car maintenance for me. I'm like, hey, robot, go change my oil and go fix my car. Now, obviously, if we don't have the right equipment, there's only so much that it can do. But on the same token, having a general purpose live-in, assistant, I don't want to use like the word slave or something, because it's, again, just a piece of equipment, even if it is anthropomorphic. But having a piece of equipment, having a device that is that useful, it would be worth the money to pay for that. And then you can imagine that every company is going to be making the same calculation, which is, okay, this thing costs me $900 a month, but if it can run your IT department, and it can, run your sales department and all these other things, I mean, it probably is very, very much well worth it. Now, here's the thing, though, is every company is going to be making the same calculation, and at $900 a month, that's way less expensive than most employees. Certainly way less expensive than even high-level employees, because imagine that this is as intelligent as a PhD in mathematics and chemistry and physics and computer science, and it only costs $900 a month in order to basically have a Einstein level genius working in your company. And by the way, every one of them is that intelligent. That is a no-brainer to say, you know what, let's get rid of all the humans and just hire robots. So I think that it is reasonable to expect or anticipate that this is what we'll be facing within 2 to 3 years. Where just imagine that you have a humanoid-sized robot that is universally capable, generally capable, only costs $900 a month to lease, and then what is that going to do to literally everything else in the economy? That would take a long time to unpack. But what I wanted to do is just share. This is where Jensen is. This is where Jim Fan is, and there's some numbers to back it up. So yeah, that's kind of it for today. Thanks for listening, and yeah, I guess let's wrap up. My novel is out, Heavy Silver, so you can go pick it up at heavysilver.net. It is 5 years in the making, 17 drafts, 5.5 years. And then the other thing is my learning community, New Era Pathfinders, over on School. That is rocking and rolling. We're at over 300 members, and we have 3 weekly webinars, plus a great community forum, and I've also got some learning content up there. So if you want to go check it out, that is at school.com/New Era Pathfinders. Thanks.